I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
2.5, picking up some dust.
From the Sea of Tranquility, President Kennedy's hope was realized. The lunar landing was the climax of the Apollo years. It was an era of excitement, of adventure, that sent the American spirit soaring.
For the new century, back to the moon, back to the future, and this time back to stay. And then a journey into tomorrow, a journey to another planet, a manned mission to Mars.
The announcement came on the 20th anniversary of man's first visit to the moon. President Bush's pledge to take another giant leap for mankind may very well rekindle the spirit that stirred the imagination and sent a generation gazing skyward to the greatest adventure of our time, space exploration. Developing new technology, including a new generation of planetary rover, is critical to the President's space initiative. In the years ahead, these cost-effective vehicles, with their sophisticated technology, will perform the advanced work of site exploration and engineering as America prepares to build a lunar outpost and journeys on to Mars. NASA has begun an important new technology initiative which will develop the technologies needed for the exploration missions. One of the technology program elements is the Planetary Rover. At the Jet Propulsion Laboratory in Pasadena, California, this new breed of space hardware has moved beyond the drawing boards. Unlike the first generation of lunar rovers, the new breed of unmanned rovers, with their stereo eyes and powerful onboard computers, will drive themselves, like no vehicle has in the past. The current rover technology owes much to another generation of hardware and to another generation of engineers. It started in the 1960s with the development of the manned Apollo lunar rover vehicle, a prototype unmanned lunar rover that never did make it to the moon, and in the years since, the job of developing a more sophisticated rover design has been passed on to another generation of engineers. These two engineers were in grade school during the inspiring days of the Apollo program. But there is a surprising continuity in the evolution of the new rover. Brian Wilcox was only 12 years old the day that the early Surveyor lunar rover vehicle prototype rolled out for testing. Brian's father was the Director of Research and Engineering at General Motors Defense Research Laboratory, where that vehicle was built under contract to JPL.
First time you try and take something out to the field.
Today, Brian is the Navigation System Manager for the JPL rover project. His job, to take the newest technology and pick up where past dreamers and engineers left off and build a vehicle that can drive itself on another planet.
On this vehicle, we have computers that are able to perform several millions of operations per second compared to perhaps a few hundred operations per second on the vehicles designed in the 60s. And so we're able to autonomously move 6 to 10 miles a day, and to do that without human intervention.
Although planetary surface exploration stalled in the years following Apollo lunar rover and Viking Mars lander successes, research and development at JPL has continued. One example is military robotic vehicle technology programs with synergistic autonomous navigation technology. The new space initiative has happened, and JPL is ready, with early versions of the next generation of rovers. Today marks the debut of Robbie, the new rover navigation test bed vehicle. Today's test is the culmination of many years of work for just one of JPL's dedicated teams. But it is also the continuation of the dream of early NASA visionaries.
The test today is to demonstrate semi-autonomous navigation. What we will do is several cycles of semi-autonomous navigation where the vehicle will take images. It will correlate those images to find the distance to each point in the scene. It will match that information with a global terrain database, and then it will plan a path based on that best estimated knowledge of the terrain surface.
The semi-autonomous navigation system will now be put to the test. Andy Mishkin.
What we've gotten to today is basically the result of integrating many different subsystems that involve many different elements. The hardware, the software, the sensing by the vehicle, the perception and the determination of what is the terrain in front of the vehicle, the conversion of that to an appropriate map, and integrating that with a path planner which takes that data and plans a safe path. And all of those pieces had to come together and work together to allow us to get to today.
The cameras should scan and do local terrain maps of this area here, and it should find the traversable path around.
Roger Bedard.
The unmanned rover navigation work that you're seeing in terms of the test work going on down here is but one part of the NASA rover program. There's other technology work going on at JPL in the power area, in the mobility area, and the mission operations area. There's also work at other centers, at Ames Research Center, at Marshall Space Flight Center, and work at universities, mainly at Carnegie Mellon University.
The rover must drive itself around a rock mound to a destination behind the mound which is not visible from its starting point. The trail is apparent to the human eye and mind, but will Robbie, with its machine intelligence, find the way? There will be no communication with the rover. It will have to navigate on its own. For the team and Robbie, the test site is as remote as Mars, 35 million miles away.
A likely place for it to be used would be on Mars, either doing sample return and exploration or survey of sites for eventual human outposts. It could do that on the moon as well.
With all systems go, Robbie begins to make his way across the landscape. By far, it's the most sophisticated of all rover designs. Its distinction goes beyond the stereo cameras that double for eyes, and the flexible backbone of its three-part chassis, and the high gear ratios that provide the muscle to climb over boulders. What makes this rover unique is its computer software, the semi-autonomous navigation, or SAN technology. Simply put, SAN is the onboard intelligence in a PC-sized computer that provides the brains to navigate and drive the vehicle. To understand how Robbie finds his way around a rock mound, for example, let's look inside. First, the electronic eyes view the mound, and the computer understands it to be an obstacle.
This is the combined panoramic data from those three scans. You see the vehicle has its 6 wheels turned into a hard left turn, and then when we go to combine that with the global data and the original data from the first path, this is what results.
Considering the programmed restrictions, the computerized semi-autonomous navigation system, like a human navigator, begins to make decisions to follow a path of least resistance. The process occurs over and over as Robbie cautiously moves forward. As Robbie is moving, the onboard computers continually monitor the movement and trigger reflex actions if the path execution is not as predicted. As Robbie progresses towards its final destination, the look of success sweeps across the faces of those who have worked so long and so hard for this moment. The semi-autonomous navigation experiment may have been only a first step in developing a kind of machine intelligence that someday will affect not only how we explore the universe, but how we live out our lives on Earth. The NASA Exploration Technologies program will lead the way as America once again reaches out into the last frontier, the frontier of space.